Trigonometric equations, part 5. Yes, quite difficult to do without your calculator. But unfortunately, much of the work in trig requires no calculator work. So that's the way we're going to have to go here too. Let's have a look at some equations without calculator. Here's a bit of reasoning. Sin A equals sin B logically means that A equals B. But of course, don't forget the quadrants, which means if sin A equals plus sin B, then it means A equals B, or where else is sin positive, second quadrant, A equals 180 minus B. Then of course we have the general solution. So let's bring that in too, and there we have it now. Sin A equals sin B. Sin A equals sin B means A equals B plus K 360 degrees, or A equals 180 degrees minus B plus K 360 degrees, K element of Z. Same thing happens for cos. Cos A equals plus cos B. Well, that means A equals B, but of course the quadrants, cos A equals plus cos B, where is cos positive? First and fourth. So the fourth 360 minus. Cos A equals cos B means A equals B, or A equals 360 degrees minus B. Of course, remember the general solution again. So we're going to take that and we're going to say plus 360, K 360, plus K 360, K element of Z. So there we are. Of course, there's nothing to stop you writing. Instead of A equals B and A equals 360 minus B, you could write A equals B and A equals minus B. Because 360 minus B, 360 minus 20, for example, is 340. Well, minus 20 takes you to the same place. So you could just write that. Useful thing about that is then you could just write A equals plus or minus B in one step if you wanted to. Tan. Tan A equals tan B means A equals B. Bring in the quadrants. Tan A equals plus tan B means that it's first or third. Therefore, first or third, 180 plus. Bring in the general solution. And we now put plus K 360, K element of Z, and there's the full answer. A equals B means A. Tan A equals tan B means A equals B plus K 360. Or A equals 180 degrees plus B plus K 360, K element of Z. Of course, let's just go back a step again there. There we are. A equals B or A equals 180 plus B. Notice if you add on 180 to B, you get 180 plus B. If you add another 180 on, you get 360 plus B, which we could get from there. So 360 plus B is really that. Because 180 is exactly halfway between 0 and 360, also because tan has a period of 180 degrees in the graph, we'll see that just now. Instead of this, we could actually write just A equals B plus K 180. You're still welcome to do it the longer way around, but this is a shorter way. Instead of two separate quadrants separated by 180 degrees, each plus K 360, we can do a single quadrant plus K 180. Right, let's look at a sin. Sin 2 theta equals sin theta plus 20. That means first quadrant, that equals that, or second quadrant, that equals 180 minus that. So let's look at the first quadrant. There are 2 theta equals theta plus 20 plus K 360, K element of Z. Theta across to the other side will end up with theta equaling 20 degrees plus K 360. There is your first answer. Now we're going to take the second quadrant. 2 theta equals 180 minus that. So that was equal to that, and then that is equal to 180 minus that with the general solution. Taking away the brackets, bringing theta across, so we get a 3 theta. We end up with that. Dividing by 3, there is our answer. So there is our answer to this equation, and we have not touched a calculator. Hopefully you could do that one in your head. Of course, it would be quite acceptable, instead of saying 2 theta equals 180 minus that, like we've done there, we can say 180 minus that equals 2 theta. 180 minus 2 theta equals that. Have a look. 180 minus 2 theta equals that. We can do the 180 minus on either side. So if we take this further, 3 theta equals 160 minus 3 theta. How did I get that? Well, I moved 2 theta to that side to get 3 theta. I moved to there, giving you minus 20 to give 160. I moved K360 across, giving me minus K360. And I wrote the equation the other way around. Which means, see there we are, that we have 53,3 degrees plus K120. Hey, what happened to the negative? Well, from an earlier video, if you watched it, about the general solution, you would have come across a section that said that minus K360 is exactly the same as K360. Why? Because K is any integer. So K is plus or minus, so if we have a minus, we may as well put a plus there. Notice, same answer from either way. So there we are. Let's try tan. Now this will explain the period a bit more of tan. But first of all, tan theta equals negative tan 3 theta. Now this is slightly different. Tan theta is equal to a negative value. If there's no negative there, I could say theta equals 3 theta and theta equals 180 plus 3 theta, first and fourth. But now tan theta equals a negative value. So the only difference is I'm going to say, where is tan negative? Second and fourth. So I'm going to say theta equals 180 minus 3 theta, because that's the second quadrant equivalent of 3 theta. Solving that across to there, 4 theta equals 180 plus K 360 degrees, which therefore gives me that. Notice K 90 degrees now. Now we're going to go for the fourth quadrant. We have second quadrant, now fourth quadrant, and we say theta equals 360 minus 3 theta. Now if we solve that, we get 4 theta equaling 360 plus K360. Do you notice that's actually K360, which is 90 plus K90, which is really K90. Now be careful, because do you remember that, in fact, tan of 90 is undefined. Tan of 270 is undefined. So tan is undefined at 90 and then every 180 degrees. In other words, tan is undefined at 90 plus K180. There we are. 90 and then every 180 on. Have a look. There's 90. 1, 2, 90. So there's 270 undefined at, which is 90 plus 180. It's undefined at negative 90, which is 90 minus 180. It's undefined at minus 270, which is 90 minus twice 180. So that's undefined. So really, we've got to cut something out of this now. In fact, so we write theta equals K 180. K90, but in fact we can't have any multiple of any odd multiple of 90. Therefore it's just the even multiples of 90, which is K180. So we have that and that. The shortcut. Remember, instead of 2 quadrants, each plus K360, we could have 1 quadrant plus K180. So the period of tan is 180 degrees. Here it explains by graph. There's one period of the graph. Notice there's the pattern, then it repeats. So therefore, I can say whatever the value is, that every 180 it's going to do the same thing, which means that one quadrant's enough. So instead of saying theta equals 180 minus that plus k360 and theta equals 360 minus that plus k360, I'm going to go for the second quadrant, theta equals 180 minus 3 theta, and I'm going to say plus k180, and that's enough. That includes everything. Solving, we get 4 theta equals 180 plus k180, which is really k180. So therefore theta equals 45 plus k45, which is really k45. But we have another but here. But those are the undefined values. Theta can't be 90 plus k180. We were talking about it earlier. So therefore theta equals k45, k not equal to 90 plus k180. There we are. There's our general solution. What about if we given sine equals cos? Well, we know a way to convert that back to sine. Sine, co-ratios. To remember that cos of 20 is the same as sine of 70. Cos of 10 is the same as sine of 80. Cos of b is the same as sine of 90 minus b. So therefore, instead of cos b, I can write sine of 90 degrees minus b. Or I can do it the other way, leave that as cos and change that to the cos of 90 minus a. Either way will give you the same answers. Let's have a look then. So if we're doing it by this one, quadrant 1, because sine a equals plus sine, so it's a plus value, therefore quadrant 1, a equals 90 minus b. Quadrant 2, a equals 180 degrees minus 90 minus b. 90 minus b, 180 degrees minus 90 minus b. And then of course we must add our general solution. So that's how we would solve sine equals cos. Let's do an example, alright? So sine of 5 theta equals cos of theta minus 40. It looks terrible. But all we do, we could convert that to sine or that to cos. There we are. Cos of theta minus 40 is the same as sine of 90 minus theta minus 40. And that simplifies to 130 degrees minus theta. So we have sine of 5 theta equals sine of 130 degrees minus 5 theta. Now, sine equals plus, therefore, first or second quadrant. So we're going to go 5 theta equals 130 minus theta plus k360. Or you're going to go 5 theta equals 180 minus that. I've done it the other way around. I've said 180 minus that equals 130 minus theta. Remember I said that was okay. Caught myself out there. Why did I do that? Well, just to avoid having too many negatives and brackets and that sort of thing. So I put it on this side. But either side works. So, this one will give you 6 theta equals 130 plus k360. This one here, well, I could get 4 theta equals 50 plus k360, or 50. I've moved the 130 across this side, 50. I've moved the 5 theta across that side, 4 theta plus k360, which means theta equals, and I've divided by 6 there, 21,7 plus k60, and there I've put the k360 on the other side, turned it around, divided by 4, divide 4 into there, 12,5, divide 4 into there, k90. There are all our answers. No calculator. Here's some more to try. Yourself. Using pause. Should be straightforward. There we are. That equals that plus k360, or that equals 180 minus that plus k360. Now we just solve both. There we are. Which means finally, you see this became theta equals minus 20, which I'm going to write as 340. 3 theta is 200, so divide by 3, so that's how we get the 120. Cos equals cos, but hang on, that's negative cos. So we'd say, where is cos negative? Second and third quadrants. So therefore we're going to have 2 theta plus 10, 180 minus the theta for second, 180 plus the theta for the third. Now we can solve both of these for theta. 3 theta, 10 goes across minus 170. This comes across minus theta, so you end up with theta. 10 goes across 170, so we've got 3 theta equals 170 plus k360, or theta equals 170 plus k360. So we divide through by the 3 there, and we end up with that answer there. Tan 3 theta equals theta. Now you can decide whether you want to go 2 quadrants with k360, or you want to go 1 quadrant with k180. I've got 1 quadrant because I'm being lazy, much easier. 3 theta equals theta plus k180. Theta goes across, 2 theta equals k180, theta equals k90. Now once again, I'm going to have to say, oh hang on, but k can't be equal to 90 plus k180. So therefore this is going to end up being a k180 alone. Silly me, I didn't put in the answer there, but you see, you can't have tan of 90 or 270. So therefore you've got to take out the 90, the 270, etc. You're left with the 180, 360, and going the other way. That's why it becomes k180. If we look at this one here now, sine equals cos. Alright, so we've said 90 minus there. That is equal to that. Right? I've gone clever here. I've said, alright, sine is equal to plus. So therefore I'm saying sine of what becomes cos of 3 theta plus 10? Well, sine of 90 minus 3 theta plus 10 becomes cos of 3 theta plus 10, or 90 plus sine of 90 plus 3 theta plus 10 becomes cos of 3 theta plus 10. So I've gone straight there. It might be easier for you to actually do the 90 minus and get it to sine and then go from there, because this is quite sneaky. Alright, now we simplify those equations, and we end up with theta equaling minus 10 plus k180, 170 plus k180. What I'm saying is, well, instead of that we can put that, neta, and k90 from there. Oh, that's very sad.